Hello, Forecaster here again, and we are back for episode 94 of the Railcraft server Let's Play. And we are once more back in the test world, creative world, and I realized my mistake in the previous video, or more accurately, I was corrected, or I had it pointed out to me. So it turns out that the wiki, as I thought, is a dirty, dirty liar, and the actual output of the transfer fluid function or method is a boolean followed by a number. So what happened is I just caught the boolean, and I thought, because it was a while since I worked on this, and I have two different versions of the program now, I got confused and thought that I had done it this way before. But it turns out that in the previous version, I just ignored the output of the transfer fluid and just assumed that it moved the fluid correctly each time, which it did. But in this version, I decided to use the return amount, and I went by what the wiki said, which I shouldn't have done because it lied. Anyway, I've corrected that and found another problem because of that check. And the problem is that I found, for some reason, I don't know why, I'm guessing it has something to do with fluid interfaces, or just the way the advanced rocketry liquid pipes work. Not sure where the fault lies exactly, but it turns out that the liquid pipes only want to insert into this tank. And we can do a quick experiment, I suppose, for this. So we'll have this come over here. And we'll take some gold, dump that in here, and then we'll power this. Gold ends up in there. But if I take some copper, dump that in there, it stays in there, and it doesn't go in here until I remove the gold. Then we get the copper. But if I do what I did here, put a refractory hopper on top of there to act as a buffer, and then we power that. No? Oh, does that only connect on the top? Yes, okay, fine. So then the hopper inserts correctly, although a lot slower. But yeah. So then we get both of them. So for some reason, the pipes only see the first tank, or the fourth tank, I guess, if you go by the order here. But I'm guessing it's tank, the first input tank it sees. And it doesn't acknowledge the other ones. I don't know if the alloy mixer does something weird. And because the refractory hopper is from the same mod, it works. But the solution, as you can see, was to just drop it down a block and then put refractory hopper on top. And I think what I'm going to do to account for that, we look over here. I have my while loop, and I'm iterating over each of the inputs. So basically, for for example, bronze, we have an operation. We move 3 copper, then this loops. We move 1 tin, then we increase the number of operations by 1, and then we start over. If we move 3 copper, we move 3 tin, or 1 tin, and so on. Now, because of that, it's going to alternate between each fluid, and so what happened was this tank, once it moved 3 copper into the metal caster, no, the alloy mixer. I keep not seeing that because it breaks the pattern. And then it put that in here, but then it couldn't move 1 tin into here, but it couldn't pull that out because there was nowhere to go for it to go, because this tank was blocked by the copper. And then the program errored because it couldn't move. It went back to copper, but it couldn't move copper into this tank because there was tin in it. And what I'm afraid might happen is actually it moves 10 at a time. Yeah, what might happen is because this refractory hopper is a lot slower than the pipes. If it, for example, if I wanted to make some electrum, it's going to move 250 millibuckets of redstone at some point into the buffer tank. And then if it needed more fluid or something else from the same stack, it might, the system might be blocked, and then it's going to error because it can't move the fluid. So I wonder if the best solution to that is to, instead of erroring when it can't move the fluid, we just pause and wait. But what I also might want to do, but I'm hesitating because I'm not sure it's going to, it might make it worse, is switch the loop around. So this loop right here, instead of iterating, doing the performed operations and then doing each fluid and then looping and then doing each fluid, I iterate over each of the inputs first and then move all of one input at once. So instead of moving 3 copper, then 1 tin, then 3 copper and 1 tin, I move all of the copper and then all of the tin. We can try that. So basically we're going to separate these and then take this, put that into there, and then at the end we have to reset performed operations to 0 so it can proceed with the same number of operations for the next input. So let's try that. So this does work. I've already made some bronze here, as you can see when I tried it out, when I finally got it to work. What a new factory cell. So everything is empty now. Of course, I haven't gotten to the return yet. So if we now make sure, all right, forgot to switch back to Minecraft. So I emptied everything. And I had an ingot's worth of bronze made in here, which I removed. So now we have the new version of the program. We'll restart, and then we'll get 1 ingot, 6 bronze, and 1 mount. So now it's moving all of the copper, which is, and then the tin, and then it made the, okay, so because it's moving a small amount, an amount below 10 millibuckets at a time, this manages to keep up. But if it inserts 250 of something, it's going to block the system. And for one fluid, it's fine, because this tank will still buffer. But once it has moved, once it moves on to the next fluid, because those recipes that included, for example, redstone for electrum had more than one. Although, I guess you could mitigate that by specifying them in the right order, because it processes the inputs in the same order each time. So the first input you go from lowest to highest, basically, so it saves the highest one for last. Could work. I should set this up so I can test the electrum recipe as well. Let's do that. Let's expand this. So let's go up. So we're going to build another stack, like so. And then we're going to have a buffer tank, which shouldn't need to be at large. And then I'll hook that up, and we need to power that. So it's always extracting. Get rid of that and that. And then we'll, there, we'll hook that up, and hopefully, yeah, the creative computer has a high component limit, or the creative processor. So we should be good there. Then we'll copy the address, and then over here we can start adding more materials now. So we're going to add redstone, and the address is going to be this. Input side, let's do down, and then output side is west, the same as the other stacks because they have the same orientation. What else did we need for electrum? Brass, no. Where's the bronze? I suppose brass works. I just need the recipe. Copper, silver. So we need to add silver because I don't think I don't have any silver in the current stack. So we'll go back here, and then we can just copy the redstone one. Rename it to silver, same address, and input side, let's do up for simplicity. I'll go back here, and then we should have molten or liquid redstone. I don't want to do that, actually. Let's use these. Fill this tank up with the redstone. And then we need silver, same thing. But the top tank. Like so. So now we have all the raw materials we need for electrum. And that should be fine once the system is... once we... No. Stop and start back up. Now, we are going to get... First, we're going to empty this. I suppose I can just do that. I have to take it out. And then we have... Oh, signalum was the one with redstone. Electrum was gold and silver, I think. Right. Let's... for signalum, and we'll do one of those. Let's see how this works. Oh. That's not... Oh. Okay, that worked. Better than I thought it would. So now that only... That went really quickly, actually. So it grabbed the... copper, silver, and redstone. So it grabbed the copper from there, and that could go into its own buffer tank. And then it grabbed the silver, which it moved out pretty quickly, and then grabbed the redstone, which could linger in here until the silver was cleared, which should have gone pretty... which apparently did pretty quickly. I kind of want to move this computer over here so it's more accessible to having to run so far. But okay, so that, I guess that works. Let's actually try requesting a higher amount. It's like 10 items, 10 ingots worth, and see if it breaks. So we'll want 1 for ingot, 4 for signalum, and then we'll do 10. And it still only produced 1. Okay. Oh. That's... Ah, right. That's because I pass in 1 here, I think. That should actually be... So parts is the cost of a single item, and this is how many items I want. So this should actually be F amount. And then if we restart... Let's actually, let's move this stuff over here. Put that there. And then I can just grab everything. I really only need the hard drive to keep the program and keep the reference in IDEA, but doesn't matter. We can do that. that up, and then this should boot up just fine. And it has the caster program on it, and now the ingot is on 3 for whatever reason. Signalum is on 1. Probably sort those by name or something so that they don't change positions all the time. But now let's try 10 and then clear the tank. Okay, so now it did a lot more. Right, yeah, so now the redstone was the big hold up, because it's the final fluid and the stacks are separate, so we have 2 on one and 1 in the other, it didn't actually cause the system to fail, which is good. I guess that is a working solution, to just separate things to where there is enough space to move to where it keeps it from failing. What I could do otherwise is to, like I think I said earlier, just if it fails to move a fluid, wait a bit. Yeah, I said that. Wait a bit and then retry. Or I could just make it work a lot slower. But of course the slowing down when it actually fails is a better solution, because it keeps it working as fast as possible in other cases. So basically all that's left is the rest, which is getting the fluid from here into the correct metal caster, which would be this one. Let's clear these out, I suppose. Made some test stuff earlier. Right, so what we want to do now, let's pop back into idea. So when we have the alloy, we're going to need to so we're going to valves, not values, valves, F item, which in the example, if I've been using ingots, so this would send in ingots, and they would close off all of the other casters and the alloy mixer, and it would leave the ingot metal caster open. Then we want to use the control, which I have up here. So what I'm doing here is I'm closing the, or I'm making sure that the input tank, which is this one, I'm removing the redstone signal from this, so it won't extract from this tank. Make sure this is unpowered, and I make sure that this is powered to keep fluids from flowing in here. Now this, actually this is a little more elaborate than it needs to be. I don't actually need this, because this can be powered all the time, because okay, some local lag there. That was weird. But yeah, this can be powered permanently, because I'm never going to want anything to flow into here. All I need is a way to keep this fluid from being extracted. Why is it lagging? That's super weird. Anyway, so let's go back into here. So we can simplify this a bit now. We don't need the... We can rename this to control side, and we can remove this second variable or second value completely. And then we're going to just get that. I'm going to comment there. Right, so after the valves, all we need to do is control set output sides mixer control side, and we power that fully. Ending square bracket there. And that should just cause the fluid to flow into the buffer tank, or from the buffer tank into the ingot caster. So let's try that out and hope I didn't mess anything up changing those things. So 3 for ingot, 1 for signalum. Could use bronze as well, but let's use signalum because we can. And let's order 20. Yes. So now it's going to be making a bunch of stuff. Fills up with redstone for a bit because it didn't have anywhere to go. I guess it alternates a bit. And stuff is empty. This has reset. And in here, oh. Okay. That's a problem. That is a problem. Okay. Maybe I should just have it pause. Is there a fluid buffer from like IC2? Fluid input, loader, semi-fluid generator, fluid regulator. This is one tank, distributor. That's still a regulator. That is one tank. Basically, I would want some kind of buffer that has multiple tanks that can just collect the fluid and then output it down as... but apparently I don't have anything like that. Just item buffers. Another solution is to split this up so that I have multiple hoppers that are inputs to the alloy mixer, like say 2. Although I realize that the liquid pipes will just split the fluid between them, which I guess would double the input rate, because 2 hoppers would be faster than 1, but that still probably wouldn't be enough. The main issue is that it completes the other stages too early. Maybe another solution would be to monitor this tank with a transposer and wait until it has the target amount of fluid in it. Tricky. So we're kind of out of time again. I might have to think really hard about which path to take from here. But I could the easiest solution would probably be to wait, have a set waiting time. Maybe I can just calculate a waiting time. What if I just calculate a waiting time depending on how much fluid is being moved, and that would, and then wait until I think that all the fluid, oh, this kind of, oh, is that, oh, okay, right, whatever. Okay, so this moves fluid decently quickly, so I just need like a second for every 20 millibuckets, or like half a second for every 10 millibuckets. So I could probably calculate the total fluid moved. I think we'll do that quickly and test it. So we'll add a variable called local total MB moved, set it to 0, and then we can set that, we'll add input parts times F amount to that. We'll bracket those together, so the order of operations, I like doing that even though the order of operations there should be correct anyway. And then, so we'll have an OS sleep, and then we'll do total MB moved divided by 10. I think that should do it. And then we'll have to reset things here, so we'll destroy that. Replace that like that. Get rid of all of the fluids. I don't know why JI keeps hiding. Okay, and then we'll reboot program. And then ingot, signalum 20. Actually, I'm going to quickly add a status print here. Print waiting for fluid flow completion. ... Then so you can tell what it's doing, that it's waiting there. Now we can try it out. And then I'll end the episode and then get 20 of those there. So now it's just going to move all of the fluids. And I'm waiting for fluid flow completion. So now it's going to, the redstone is going to go into there. And hopefully all of it flows into the correct place before the program proceeds. It looks like it will. Yeah. More than enough. This is not... Why is it not extracting? This is still locked. Maybe I should divide it by 20. Seems way too... Seems like I... It's waiting way too long. But why is it not extracting? That's on. This should be fine. This should still be powered. Or unpowered, I mean. What's it doing? It's still waiting. Should have had it print how long it's going to wait. But this is not working all of a sudden. This has to be similar to what happened before, when I thought I had this. I don't know if that made it into a video. This should be it should be extracting. I don't know why it's not. This is still sleeping. Alright, I'm going to end the episode here. I'm not sure what happened now with this stuff, because it should work. I'm going to adjust the sleeping, the wait period, to try to time it correctly, because apparently I was way off, or something broke. Maybe the world collapsed. Who knows? I should be able to put that in there. Oh, there it goes. Okay. That was strange. So now we have a bunch of fluid in there. This is still waiting. Maybe an override. It should set a time, it should wait for input or for the timeout. But I still need to adjust the time so it's not completely ridiculous. I'm going to wait for this and see how long it takes. But I'm going to end the video here, and we'll be back in the next one, and hopefully this should be it so I can implement this on the server. But I'm going to need to upgrade the controlling computer first, because I'm going to need to add more components. But with that, I will see you in the next video.